So today we're starting our new unit, or our first unit in grade 11, which is quadratics in vertex form. So that's going to introduce us to the quadratic function, and specifically the one in the vertex form. And we're going to start by looking at some modeling of quadratic relations. We're going to look at some of the equation of it, how does it look like in a table of value, and how is it going to look like in a graph. That's what we're starting with. So we're going to start with the distance traveled by a boy on a bike is modeled by the equation y equals 3x. If I look at this equation, does it look like it's quadratic? How do I know it's a quadratic? So it's simply looking at, as we spoke earlier when we were graphing linear functions in the review, this x has a degree of 1. So I kind of know that it's not going to be quadratic. It's going to be rather linear. So if I look at the table of values, what I have here, so I plugged in values of x into my x. So if I plug in 3 times 0, I get 0. If I plug in 3 times 1, I get 3. 3 times 2, I get 6. 3 times 3, 9. 3 times 4 is 12. These values of x I picked. So by looking at the y values, we are going to do something that is called first difference. So when I do the first difference, I have to take the y2 and subtract it from y1. So if I do 3 take away 0, I'm going to get 3. If I take 6 take away 3, I'm going to get 3. 9 take away 6, I get 3. 12 take away 9, I get 3. So what you notice here, you notice that the first difference, anytime I do y2 minus y1, I am getting a constant number of 3, which is normal for linear functions. So if you have a linear function, if you have a table of value and you do your first difference, which means you do y2 minus y1, and then you get a constant value, in this case it's 3, you're going to know it's a linear function, and you don't have to do your second difference. Now, if I want to graph this, so if I'm going to graph this, so I know it's 0, 0 because of the x and the y, so it's 0, 0. Then I have 1, 3. So if I go 1 on the x, I'm going to go 3 up. If I go to 2, 2, 6. Right? And then I can kind of graph the line. Okay? So that's a straight line. So far what I looked at the equation. The equation has a degree of 1. The table of value, when I did the first difference, it gave me a constant first difference. And then when I graphed, I got a straight line. Let's look at it. So looking at the second example, I have the height of a falling marble is recorded and modeled by the equation y equals negative 5x plus 2. Also looking at this, I can say that it's a degree 1 because the x value has no number on top of it, which is degree 1. So I know it's going to be linear by just looking at the equation like this, right? But if I have a table of value, I'm going to have to test the table of value, and then I'm going to have to graph. So again, the values of x that were picked was 0, 1, 2, 3, 4. You plug in the value of x into the corresponding, where x is. So it's going to be negative 5 times 0 plus 2, which is going to give you 2. Plug in 1. So negative 5 times 1, that's negative 5. Add 2, that's negative 3. Negative 5 times 2, that's negative 10. Add 2, which gives me negative 8. Negative 5 times 3, that's negative 15. Add 2, that's negative 13. And then negative 5 times 4, that's 20. Add 2, that's negative 18. So far I only found the y values. Right now I'm going to have to start with the first difference. So that's my test to see if it is linear or not. Remember, with the first difference, we do y2 minus y1. So we're going to start with -3, and then we're going to subtract 2. So that's going to give me a -5. Then we're going to take -8, and then we're going to subtract -3. So in this case, if I do -8 minus -3, that's going to be -8 plus 3, which is going to give me also -5. Following by -3 minus -8, so -13 minus -8. So that's again another case of minus and minus gives me a positive, which is -5. And the last one is -18, take away -13, which is going to give me a -5 as well. So looking at my answers here, I'm getting -5, -5, -5, and -5. So that's a constant first difference. Which means it's a linear function. Now to graph this, I won't be able to graph all the points. So if I go 0, 2, it's going to be my first point. 1, -3. So I'm going to go down 3. And then 2. That's -8. I don't know if I'm going to be able to fit that. Yeah. So it's about here. I won't be able to fit all the other points, but then this is as good as I can do on this graph, okay? So again, it's a line. So that proves it's a straight line. Now looking at the third example, the height of a ball thrown by a child modeled by the equation y equals -2x squared plus 8. So the difference between this equation and the previous equation is that you can see a squared on the x. That's an indication of a quadratic function. So right there, that square that you have on top of the x, that's an indication of a quadratic function. Now we're going to do exactly the same thing as we did with the linear function to fill out our table of values. So we're going to plug in 0, 1, 2, 3, 4 in for x. So if I plug in 0 in for x, -2 times 0 is -2 plus 8. Sorry, -2 times 0 is 0 plus 8 is 8. Now I'm going to plug in 1. So 1 squared is 1 times -2, that's -2. Add 8, that's 6. Then I'm going to plug in 2. 2 squared is 4 times -2, that's -8. Plus 8, that's a 0. If I plug in 3, -2, 3 squared plus 8. So 3 squared, that's 9. 9 times -2, that's -18 plus 8, that's a -10. And then if I plug in 4 squared, that is 16. 16 times -2 is -32. Plus 8 is -24. So as you can see here, I have my y values. Now what I have to do is I have to find my first difference. So as usual, the first difference, you do the bottom minus the top. So 6 take away 8, that is -2. 0 take away 6, that's -6. -10 take away 0, that's -10. -24 take away -10. So that's the same thing as saying -24 plus 10, which is -14. Now, what you can see here is that the first difference is not constant as we've seen in the linear functions. So that's why that's normal for quadratic. You won't find that the first difference is constant. Otherwise, it will be linear. So right now, we're going to go into what we call the second difference. So the second difference is when we take the first difference and then we subtract them from each other. So we're going to do negative 6 minus negative 2. So negative 6 minus negative 2. So that's going to be negative 6 plus 2, which is negative 4. And then I'm going to take the next one, which is negative 10 minus negative 6. So negative 10 plus 6 is, again, negative 4. Then I'm going to go to negative 14 minus negative 10. So that's the same thing as saying negative 14 plus 10, which is also negative 4. So what you notice here is that the second difference is constant. So a quadratic function will have a constant second difference. Now if I'm going to graph this, so I'm going to go up maybe 10 here, negative 10, negative 20, just so I can fit some points. 0, I have 8, so it's about here. 1, I have 6, so it's about here. 2, I have 0. 3, I have negative 10. 4, I have negative 24. So if you look at this, this is not linear. It's more like a curvy shape. And then, as you know, it's a quadratic function, so it's not going to be linear. It's going to be curvy, and then you're going to see this is only half of the curve. The actual look of a quadratic function is going to either be like this, we call that a parabola, or up, opening up, so that's another shape. That's the same, parabola opening up or parabola opening down. So what I want you to do is I want you to explore this table, and you are going to fill it up. Okay, so it's going to take some time for you to fill it up. You know it's going to be quadratic, so go ahead and do that.